Howdy, y'all. Professor Parks, PhD here. I make content on astronomy, science skepticism, and mental health. And today I'm going to be talking about lunar eclipses, specifically the one that is scheduled for later tonight. I'll talk about where, or rather, I will talk about how it happens, but more importantly, I will start off by talking about when can you observe it. It is going to be based on your location. Unfortunately for all y'all in the European folks, Brits, and Russians, Chinese, or anyone on the opposite side of the globe, then us, you will unfortunately not be able to see it either at all or only partially. This is almost exclusively a Western Hemisphere effect. So anyway, howdy y'all. Howdy Roy. Ro, sorry. Trying to get used to that. Irish names are weird. Howdy Nimrod, Judy. Yeah, so I do apologize. This is going to be a little bit rough because I was not expecting it, because they gave us all of 2 hours notice, but our local Fox station actually came here and interviewed me for, well, my director and then me, talking about the eclipse. So I spent majority of my afternoon dealing with that. So my first 2 live interviews. So watch out, Neil deGrasse Tyson. So that was very exciting for me. And then afterward, I basically hopped on Culture Cats stream. If you are not subscribed to Culture Cats, please go over there and do so. Also, while you're there, you might as well swing over to 8 out of 10 Cats debate channel and sub there, because Culture Cats helps run that as well. So yeah, so we're gonna basically do this a little bit freeform, but I do want to address a couple of things about the stream that I was on Cats. I'm not gonna spend a lot of time on it, because that's not what this stream is about. But I want to say that I want to state that I was wrong about the controversy surrounding the speed of light in terms of how it has been measured, either one way or two way. And I've watched the Veracity video, and the rationale, the scientific rationale to it is sound. I will also be checking out the 2008 paper that says that the one-way speed has been measured. Sadly, Veracity didn't actually show the paper that debunks it, but hopefully I can find that. But again, I want to say that I was wrong on that. I was not aware that this controversy existed. I have some significant questions, and this is obviously bigger than my brain. So I've reached out and to the biggest brain in this sphere that I know, and that is Dr. Clive Wells. And so I'm going to pick that up later on. But the first thing that I would question is that the way that the speed of light was first measured, it was actually not measured by Fizeau, it was measured by Ole Rømer. And he did so by looking at the period changes of the moon Io. And what he noticed was that depending on the Earth's position to Jupiter, the period actually was noticeably different, or measurably different. And what he attributed that to was the difference in light travel time. Granted, the measurement of the speed of light that he got was drastically too small. And but this was like an 18 something or other. You can't expect the dude to have precise timing instruments. The first question that I would have, if there is an instantaneous speed of light, if there is a asymmetric, if the speed of light is not invariant as a function of direction, then it would have to be explained to me why that effect can be seen on one side of the sun and also on the same opposite side of the sun. That would seem to indicate to me that the speed of light is instantaneous in one direction towards the Earth, that there is a that the Earth is a preferred point in space. And again, if Will's argument is that the light coming from the vast universe is in fact instantaneous, then again, one would have to give me a scientific justification for why the Earth would be the center of that. Because again, I would think that if you were on Mars, then you wouldn't have that effect. But bigger topic than what I can do with. And like I said, I just learned about this. I will be looking into it a little bit, but don't expect anything from me on that, because I have other topics on my mind. My next major topic is going to be the celestial theodolite that has been circling around within the Aether community. But last time, I was wrong. I did not know that this controversy existed. Thank you for bringing it up so that I can learn and figure out what's going on. So, all right, now, Parksy is a Fox TV personality. Yeah, exactly. No, this is local news, so I don't think it's nearly as biased. It's actually news. Actually had some pretty interesting conversations about how both the meteorologist who did the interview and the cameraman who filmed it, how they got into news and what events actually got them excited about doing the news and getting into this business. It was a marvelous experience all around. All right. So, eclipse. So tonight we're going to have a total lunar eclipse. Now, eclipses happen twice a year, and I'll get into why that is later on. But it depends on where the Earth is in its rotation with respect to the moon as to whether or not we can see it or how we see it. So, according to her, and I'll take her word for it for now, is that we haven't had in the Northern Hemisphere a total lunar eclipse in 3 years. Even though that we have eclipses twice every year, again, it depends on where you are located on the Earth, when the eclipse happens, whether or not you can see it. Unlike with the solar eclipse that has a very thin 50-kilometer or so line all across the surface of the Earth, that only those people in that location can see the totality. With a lunar eclipse, if you can see the moon at that time, then you will see the eclipse. So basically, an entire hemisphere of the Earth can see it. However, folks like people in China and definitely in Middle and Eastern Europe, they won't be able to see it because it will be daytime when the eclipse actually occurs. So, thank you, Greg. I appreciate it. I was getting a little bit of hate in the comments section, which I was trying to ignore, but hey, that's part of the game, right? So if you're interested in, let's put this over here. So many tabs. I have such high IQ research going on. It's incredible. So much high IQ going on here. Let's see. There it is. Let's do that. Oh, this was up because of a recent Sabina video about climate change. And so I needed to refresh my memory as to how you actually get error bars out of a confidence interval. So that was fun. But let's go to the Googles. Now, what I would do is I would type in March lunar eclipse 2025, time Fairfax, Virginia, because that's where I live. And I would go down to time and date. So this should be your first hit. So replace Fairfax, Virginia with your location. Click the first link. Oh, and those are the people who interviewed me. And you should get to something like this. And so you get the global event, not really, but I just described that. It's definitely a total lunar eclipse for Fairfax. It begins technically at 11:57 p.m., so around midnight tonight. It will reach its maximum, meaning that it will become completely it will be the darkest it will ever be. The entire moon will be in the shadow of the Earth's shadow. The moon, the moon will be entirely within the Earth's shadow, and it will appear red. And I'll get into why momentarily. And then basically it'll end at 6 in the morning. The duration is 6 hours, 3 minutes. That is a little bit misleading because that includes the entire eclipse. And what do I mean by that? Well, let me see if I can bring this up. Like I said, it's going to be a little wonky today. Is it this one? Show is. All right. I don't know why I said it that way, but, let's go with it. So this simulation, which is very crude, but it gets the point across, not to scale in any way whatsoever. But it does illustrate the points that I'm going to go over. Oh, it actually does scale the shadow appropriately with distance. Well, anyway, this is done by the folks at the University of Nebraska, Lincoln. Great simulations they have. I recommend if you're interested in astronomy, you're interested in learning more about the mechanics of, why you can see certain stars during certain times of the year, definitely Google NAAP astronomy simulations or astronomy labs, and that'll get you where you want to go. It'll have a whole suite of these things. So you have the sun, you have the moon, or the earth, and then the moon. Real quick question. Do you need to wear special glasses for solar eclipse? Or you do need to wear them for solar eclipses? Do you need to wear special glasses for lunar eclipses? That is an excellent question. And the answer to that question is effectively no. What I mean by effectively is that if you want to watch this from straight off front to back, and you're going to magnify it in any way with a small telescope, for example, what I would highly recommend is using a lunar filter at the very, very beginning, because the full moon is bright. And if you magnify it, it's going to be even brighter. And so you're not going to damage yourself per se, but it's definitely going to mess with your vision a little bit. So at the very beginning and at the end, I would use a lunar filter only if you're planning on magnifying. Outside of that, if you're just looking at it, then no, you do not need any special glasses or anything like that. Thank you, Judy Bassett, for the 10 euros. And thank you, Ferocian, for the glasses or for the question. All right, let's get to this. You might notice something funky. This in the shadow. So you have this dark gray area, and then you have this lighter gray, although it looks yellow on my screen. You have this lighter area over here. Generally speaking, when you're talking about terrestrial shadows or shadows made by things in your everyday life, when you say shadow, you're actually specifically referring to the umbral shadow. So this is known as the umbra, or the umbral part of the shadow. That is where the light is most attenuated, where most of the light is being blocked out by the object, in this case, the Earth. But you also have what is known as a penumbral eclipse. This is where only part of the light is being blocked, and so the object will appear dimmer, but it certainly won't appear as dim as you would expect if it were in a shadow, as we know colloquially. So yeah, I generally don't generally don't notice penumbral shadows just around me on the around the Earth or around me in everyday life. I have noticed it when I was at the university or at LSU, Louisiana State University. There was a long shadow cast by a corner of Tiger Stadium, and you can definitely, it was a nice little progression. The penumbral shadow split off from the umbral shadow, and it got larger with distance, as you can see here in this diagram. I also noticed on cars traveling on the interstate, I think you really need a sharp edge in order to see it. So ordinarily, the moon will either be below or above the Earth. Now, one question you might have is, we have a situation where you have a lunar eclipse when the moon is directly behind the Earth and the sun's to one side, and the phase is full. So the question would become, why don't you have eclipses all the time, every month? The reason for that is because the lunar orbit is inclined 5 degrees to the Earth's orbit. And so you only get eclipses at the points of intersection of when the moon is directly in line in its orbit, when it crosses over the ecliptic or the Earth's orbital path. Ordinarily, you can imagine from here, think of this as the moon is going into the screen or potentially coming out of the screen. So I'm going to treat it as going into the screen. So most of the time, it's going to go either below or above it, depending on its position in its orbit. You might think to yourself, 5 degrees, that's nothing. But you have to remember that these things, again, this is not to scale in any way. The moon is 388,000 kilometers from the Earth. And so just a small angle of deviation it results in a huge linear distance at the place where the moon is. So for the most part, moon isn't really anywhere near the Earth's shadow. But you can have what is known as a penumbral eclipse, where the moon passes only within the penumbral parts of the shadow. So it's going into the screen. The umbral part of the shadow, the dark part of the shadow, is above it and will never cross the lunar surface. So that's a penumbral lunar eclipse. You can have a partial lunar eclipse where the moon will only partially be obstructed or fall within the umbral part of the shadow, and then the rest will be eclipsed within the penumbral part of the shadow. But tonight we have a where the moon passes completely within the umbral part of the shadow. So now let's flip this around. Now let's take this as a top-down view of sun, Earth, and moon. So we have that the moon, is down here. It's kind of like right here at the moment, and it is moving in a counterclockwise direction as viewed from above. It's going to come in. It's going to enter the penumbral part of the shadow. It will enter the umbral part of the shadow, go back into the penumbral, and then finally leave. So that 6-hour duration that I mentioned on this page So if you go to time and date and you go to the fact that it begins at midnight and it ends at 6 in the morning, and so the entire duration is 6 hours, 3 minutes, that includes the penumbral part of the eclipse. Now, I will say, before I play this clip, if you can see a change in the brightness of the moon when it enters the penumbral part of the Earth's shadow, you are a much better observer than I am. I have never been able to say, definitely that is getting into the penumbral part of the shadow. So most people, when they think about a lunar eclipse, that's not on their radar. What they really think is when does the moon actually start getting dark? Actually, let me just play this entirely. So again, this is on timeanddate.com. Very good tool. And so here we have the extent of the Earth's penumbral shadow. You have obviously the moon, and then I hit play. Then at this point, this is the beginning of the eclipse at midnight. The moon is passing into the penumbral part of the shadow. And then around 2:25 a.m. my time, it's going to start going into the umbral part of the shadow. And you can see the nice curvature of the Earth blocking out the lunar surface. And then it will become total. And then around around 3 o'clock in the morning, it will be totally eclipsed, and then it will reverse itself. The actual time that the moon spends in the umbral part of the shadow is 65 minutes. So if you are in the eastern seaboard or on the eastern seaboard, then I would take a nap and really get up around 2:15 so that you can get outside and actually start looking at the moon around 2:30. Then you should be able to see, you should start to see the moon actually being overshadowed by the Earth. You'll actually see chunks taken out of it. And so, yeah, that's what's going on. And apparently you can also see Dr. Clive Wells' moon laser during the eclipse. Yes. So, thank you for bringing this up because I almost forgot to do it. And let me stop this. So, as Stephanie rightly points out, you can still see the moon. Well, science does not claim, astronomy does not claim that the shadow of the moon is going to block out all light from hitting the moon from the sun. Some of the light is going to get refracted, or rather, the Earth's shadow is not going to be perfect or absolute opaque. So when something goes into the shadow, it's not going to go into darkness, absolute darkness. It's simply just going to get extremely or more dim. Now, the reason why it's red is the same reason why the sky is blue. When photons are streaming through the atmosphere, the Earth's atmosphere from the sun is putting out color or light in all the colors of the rainbow in roughly the same intensity. It's a little bit high on the green end than anywhere else. But for argument's sake, let's say it puts out equal amounts of light over all colors. That beam of light from the sun hits the Earth's atmosphere. And because of the characteristics of a nitrogen atom, that light, when it interacts with the nitrogen atom, is going to cause blue light, or light with bluer wavelengths, to scatter in random directions all over the place. That bluer light will then hit another nitrogen atom. It will then scatter in another random direction. And so because of that, what's called Rayleigh scattering, the light is going to bounce around all of these nitrogen atoms across the entire sky, and it's going to be almost exclusively blue light, and that is why we see the sky as blue. The longer wavelengths, or everything, the early part of Roy G. Biv, all of that stays in a fairly concentrated beam as it comes down. Again, there's some wavelength dependence when you talk about orange is going to be a little bit more diffuse than red and so forth. And so that's why when you look closer to the sun, do not look at the sun directly with your unaided eye. Bad news, no bueno. As you look closer, the shading of the light actually is different. It becomes a lighter blue as you get closer. But my point is that those longer wavelengths, that orange light, the yellow light, the red light, comes down in pretty much a concentrated beam. Now, that's during the day. Now, let's go back to this representation. And again, this is meant to be simply a cartoon representation. This is not to scale in any way, and Oh no! Rocky! Rocky! This is Rocky, everyone. This is a plant that I have successfully not killed yet. It is top heavy. Rocky, where do you want to go? I need leaves to grow. There we go. Yes? No? Yes? Come on, Rocky, work with me. I got a stream, dude. What's up? Okay, for right now, you're going to live on the floor. I will deal with you later. Man, if I stream from home, it's cats. Stream from here, it's plants. Can never. Some living creature is always going to make this, make a hassle or make a scene. Anyway, again, this is simply illustrative. This is not meant to be true to life. It is simply to represent the umbra and the penumbra. But you can see that the umbral part of the shadow is not perfectly black. It does not block out all light. When you get to this area here, what's not shown is that the light is streaming off the sun and hits the sun or hits the earth basically parallel as straight lines. If you think of light as light rays. When it hits the earth, obviously the light that is impacting most of the surface is just going to get hit or is just going to be absorbed or blocked by the light. But the light that hits basically the top and bottom, or rather the sides of the earth, what we would refer to as the terminator line between night and day, when it hits that part of the earth, it is going through the atmosphere. And as I just described, blue light is going to be scattered in all directions. And in this case, the light is being scattered into space. And so what's left is simply the redder wavelengths of light. Those wavelengths of light, nitrogen doesn't have any use for it. It just goes straight on as it ordinarily would. It diffracts a bit because of, again, it's moving across a solid surface. And that light, so then the red light comes in and actually hits the moon, hence why we can still see it, and hence why it is blood red or reddish in color. So, stop screen. Okay. Cue Terminator music. Thank you. Lovely plant. Yes, I really wish it would grow. I really wish my plant would grow leaves on the other side to balance itself out. But a plant disturbing the stream is creative. Thank you. Glad someone appreciates it. But anyway, let's get back to this. So what I've been showing is Fairfax, Virginia. So the times that I've stated, again, just to say here, oh, I actually got that time wrong. It'll start the umbral phase at 1:10 a.m. It will be completely engulfed at 2:25. We'll hit the middle of the shadow at 2:59 and then start coming out at 2:36. So again, apologies for saying that. But what I would like you to take notice of is as the moon goes through, it seems to go through this arcing motion. In actual fact, at this scale, the moon is pretty much just going through a straight line. The reason why, or at least the primary reason why the moon appears to be rotating is that way, is because of something referred to as field rotation. This is the same with with an alt-az telescope. Is if you look at a celestial object on the sky, when it's in the east, north is going in the east and in the south. North is behind you. North is like over here. And so if you have Orion, like here in the east, if you have Orion here in the east, that clock behind me is Polaris. then north along the celestial sphere is going to arc in this direction from me through Orion back to Polaris. And then as it goes through its motion, it's going to rise up to top, and then it's going to set in the west. And you can see that it's not going to do this sort of thing. This is always going to point north along the celestial sphere. And so that will cause the Orion to rotate its view with respect to the Earth, such that that line is constantly being shown to the north. And so the moon itself will appear to rotate. Well, the shadow also will appear to rotate. And so here again, come on, start up. See, the moon is rotating. The Earth's shadow is also rotating because of a similar effect. Now, it's interesting to me that there is, not interesting to me. I'm wondering, I thought about it today because let's say I want to go, if I have a friend of mine who lives in the city of Angels. Hold on. Here it is. Los Angeles, the city of angels. What would they see? So for them, you have that the eclipse will begin at a much more convenient 8:57 p.m. Maximum will be at midnight. It will truly be overhead. It will be as high up in the night sky as it's going to get. Actually, I really wish I was in LA right now. Not the only time you're going to ever hear me say that. But for this eclipse, I would really love to be in LA as opposed to here. And then it ends at 3 a.m. Notice that with the eclipse in Fairfax, the shadow began encroaching onto the lunar surface from the bottom left. Here, it begins encroaching onto the lunar surface from the bottom, and actually a little bit bottom right. And so the orientation of the eclipse is going to very well be location dependent. And I know it's really late at this point, but I'm hoping that maybe I can find videos of the eclipses in various locations that have not actually accounted for field rotation, because this is predicted for a globe. This orientation is predicted on a globe. I don't know, or at least I've not seen, any sort of explanation for how you would get this effect on a flat Earth. Actually, I've never really seen a good representation of how you get eclipses, period, on a flat Earth. But I'm wondering if this can be yet another fun little exercise that people can do to essentially prove the globe model, or however you want to talk about it. And so again, Lisa, if you're not, this is on, as you can see, timeanddate.com. So for any of you out there, you can just go up here and put in your location. Now let's talk about, let's pick a random place. Let's see if I can spell it right. I can't. Fudge. All right. Nope, can't do that either. Fudge it. Let's do that one. God damn it. Yeah. That's where I was going. For whatever reason, I thought it was Banny something or other. Not Bally. But let's go to Dublin. So can Dublin see this? Well, kind of, sort of, yeah. The eclipse starts at Why does this seem? That is Dublin, Ohio. What? There we go. Well, let's go with something that's actually in Ireland. Assuming I got this right. Yes, that's in Ireland. So can they see it at all? Well, the eclipse begins for them at roughly 4 a.m. Goes through. The dark part of the eclipse, what we normally would refer to as an eclipse, actually starts at 5:09 in the morning. And then it gets, there's a lovely thing about this animation. You'll see it in a second. It'll go, they can see it. They can actually see totality at 6:30 in the morning. Oh, I thought, and then it quickly goes below the horizon. So totality begins when the moon is 3.2 degrees above the horizon. So you ain't going to see totality, but you might be able to see just a little bit of the partial lunar eclipse given your sight lines. And yes, I do realize this is Ireland, so weather probably, I didn't expect the weather to cooperate. Unfortunately, the weather here is going to be iffy. Our forecast looks to be around 30 to 50% cloud cover. If it's patchy, that actually can be, that I'm actually hoping for that, because if it's patchy, you can get these clouds passing in front of the moon, and it looks really creepy, really cool. I do plan on taking a video of this, assuming I can find enough power cables. Unfortunately, I can't live stream it because the instrument that I'm using to take this video is actually my C Star, and I have yet to be able to figure out how to live stream the view through the C Star. I know it's possible, I just haven't taken the time to actually do it. So that's in Dublin. So again, or sorry, Ballynacore. I'm fully aware I probably just butchered the shit out of that. Let's talk about Rio. Let's talk about all you folks in the Southern Hemisphere that constantly get overlooked. Oh, Australia? What? What is going on here? Yes. Oh, people in Sydney. We'll go to Sydney and see what's going on there. Rio. Your eclipse starts at 12:57 a.m. becomes maximum at basically 4 a.m. and ends around 6. So this is what you would see. Here, unlike with LA, the shadow actually begins the bottom or the top of the moon as opposed to the bottom. And then you have moon goes, or the Earth, moon goes into the Earth's full shadow or umbral part of the shadow. Turns a lovely shade of pinkish red. And then goes out of it. Total eclipse, you're talking about, it's going to be fairly low on the horizon, about 25, 30, or about 30 degrees. So abouts when, well, 26 degrees when it's total, when it's in the middle of the total eclipse, and then around 33 degrees when it starts. So as I know, I have a few few people watching from the down under. So what if you live in Sydney? Well, for y'all, it is going to be partial because the moon is going to be below the horizon at some point. but so it's actually going to start off below the horizon for y'all. Where are you? And so you won't see it until the 14th on Friday, the 14th at 7:13 p.m. That's when it'll pop up. That's when. So that's basically when it's just on the horizon. And so depending on your sight lines, you might get to see a little bit of it as it goes up. Very soon after sunset. It will obviously be in the eastern part of the sky, as opposed to the western part of the sky where the sun is. So yeah. That was, I was hoping to do a video like that earlier today, but as I mentioned at the top of the hour, I got caught up doing live interviews for the first time in my life. That was very, very cool. And then obviously I had that stream with Katz and Will Duffy. What if you live in Sydney? You're a loser. Hey, take that up with Tony. I ain't going to touch that. And of course, you'll need to check out your local forecast to make sure that you can see this. You can take pictures of the moon with through your camera. Depending on how old your camera is, you may or may not see surface features, but you will see the going in. For a tip, or when the moon changed shape. As a tip, if you can do it, I would get into the manual settings of the camera and actually lower the gain or lower the exposure time, because essentially what's happening on most automatic settings, the moon is going to be overexposed. You have so much light coming from the moon hitting the CCD camera that the camera is incapable of collecting all of it in a very short period of time, and so it will just blossom out, balloon out. It'll just be really, really bright, and that brightness will start to bleed out over the surrounding area. So what you want to do is you want to be able to, I believe I would recommend turning the gain down if possible. If not, then go to the exposure time if you're able to do it. The ISO, I'm not a photographer, so I'm not entirely certain what ISO really means or what it stands for. It's not something that astronomical cameras really deal with, but I think if you adjust that setting, you can also adjust effectively the gain and be able to see it. Let me get to this real quick. Let me just finish off this setting. But I just found out that apparently for Samsung, newer model Samsung phones, AI is going to try to help you out. And AI is going to try to fill in any gaps that the camera cannot resolve. And so supposedly, I was told this by one of my colleagues today that it will actually just fill in the moon. So when the moon starts getting cut off by the eclipse, it will actually just show you a full moon. I think that's really, really weird. And, but that's what the robot overlords want. And so that's what we're going to get. I doubt that will be a problem for anyone watching this, but just be aware that might apparently happen. For this, Lisa, absolutely. I have a C-Star, which Judy Bassett helped finance. It is, from a cost standpoint, it is the best by far telescope / imaging system you can get. It is a small aperture, so the aperture is only about 2 inches. But the camera is very nice. It's created by ZWO, which manufactures very nice cameras, very nice color cameras. The price point's around $500. So I know with the given economy, For some people, $500, no big thing. For others, that's a considerable sum. But when you look at that scope in comparison to other scopes, for that same amount of money, you can get a non-motorized, non-smart, so you actually have to move it manually, telescope that's about 6 to 8 inches in size. It's called a Dobsonian. But like I said, you have to manually move it around, and that's not including any kind of camera. You can get adapters to put onto the eyepiece holder, and so that you can use your camera phone as an adapter. But again, that's just adding a level of complexity to it. If you compare it to more professional citizen setups where you're talking about a dedicated CCD camera attached to a 6-inch telescope, you're easily going to be spending in the neighborhood of $2,500, if not $3,000. So for the price point, this is, I can go on and on about the C-Star, and I should make a video about it. It is easy to use. You have the app actually makes sense, unlike some of its competitors. It's very easy to set up. There's very little calibration that you need to do. And it takes fantastic pictures, in my opinion. Let's actually, sorry, this video is going to be sponsored by C-Star. So I don't know if you are a fan, Lisa. I haven't seen your name before, so I don't know how long you've been with the channel, but you may know that I have a C-Star and I've been using it for observations of the sun. And for some reason, this is not coming out nearly as well as I would like it. This is an image I took on March 21st at 3:01. So this was a quarter moon. This was done at 3 o'clock in the afternoon. And so this is an image. For whatever reason, it's not downloading properly. So it's a little bit more pixelated than it does on the looks on the app. But that's a picture of the moon that you can expect. So you can imagine what it looks like when it's at night. Actually, you don't have to imagine. Here's a recent image. Again, it's more pixelated than I would like. This is an image of a sunspots on the sun. All right. Hopefully, I don't have any dirty pictures in here. Cat pictures, more cat pictures, lots of cat pictures. I haven't actually gone. Okay. Here is a 33-minute image of the Orion Nebula that I took. So the camera tracks the automatically. Well, when you said go to Orion, for example, and you tell it to start taking images, it will take very short exposures, like 20-second pictures, and then it will just constantly add them on top of each other. And it did that for 33 minutes. And so this is as if you were looking at, or this is if you, well, not as if, you're looking at the telescope for 33 minutes and collecting all of that light. That is what the picture would look like. Or that's what Orion would look like with a really, 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 really big telescope. Again, this was not something that, and when it comes to creating these images, it does it by itself. You can also get the raw data files, the FITS files. So as you become more proficient with astrophotography, you can actually use the actual data, the big files, and start manipulating those and doing stacking on top of what this does. And you can start editing the colors or what have you as you would like. This is basically right off the presses. So I don't think I've touched this image up at all. So I haven't done any kind of correction for contrast or brightness or anything like that to try to pull out some of those nicer features in the background. So I cannot recommend, yes, C-Star, bueno. I cannot give it any more of a positive review for that. I loves me some Orion. So here's well, that's actually 12-minute. 41-minute. You can also see that field rotation that I was talking about here. It's, you basically, you got it pointed in this direction. In the previous image, it was pointed more in that direction. And then I'm trying to get to, nice sunspot image. Yes, I take a lot of selfies and videos of myself. Yes, I am full of myself. Oh, look, moon landing stuff. Buggy. That's at the Smithsonian. Wow, it has been a while since I've done any astrophotography. Here is a really deep image. This is basically 220 minutes on a reflection nebula with the very romantic name NGC 281W. It's in Cygnus, if memory serves. Here is basically M33. It's 151 minutes. Again, it gets a little weird when it comes to stacking because, again, this I didn't do all in one night. This was multiple nights, and I stacked them together using a function within the app. But I stacked multiple nights worth of data together, and because of that field rotation that I've been talking about, you can see up here it gets gets a little bit fuzzy. Down here, the reason why it's fuzzy is because it doesn't have nearly as many images of the center as it does towards the edge, because again, thing rotates. So yeah. Thank you, Judy, for allowing me to have that, because it's, like I said, it is fantastic. Please no pictures of giant ogre Oakley. I don't think I have any pictures of Nathan, so no worries there. No worries there. Lisa, you hang out on Toon's channel. Okay. Well, welcome to the channel. Yeah, and that's basically it. If anyone in the audience would like to ask any questions about eclipses or about astronomy, please feel free. Those costs with or without moon tariffs. The current administration's policy towards the grays is, said too much. No, there is in fact no import-export to the moon to an alien species called the grays. That is completely made up. Please ignore that I just mentioned that at all. Only in Ireland can an inch be a mile. Funny you should mention that, because I just learned that there's a town in Ireland called Inch. And also a town called The Hand, which is just, weird. Granted, American, we got some funky names over here. We particularly like to name stuff after much prettier cities of the same name in Europe, but it's just weird. So, no tariffs, they became a state. I also can make no comments on whether or not the administration is in fact going to make the moon the 57th state. That may or may not happen depending on, how the grays feel about it, assuming that the grays even exist, which they don't. So yeah. All right. Well, I will hang out just for a little bit to make this an even hour. But yeah, if you're new to my channel, particularly if you're new because of the stream that I did on cats, on culture cats, welcome. As I said, I like to do, my content is primarily astronomy, science, skepticism, and mental health, although I am seriously considering chopping off the mental health and putting that onto another channel. Long time ago, I created a channel called The Mad Scientist. And that was meant to be where I spoke about my own mental health and, how, essentially the trials and tribulations of having mental health and mental health illness or mental illness in academia. I think I'm going to resurrect it. The main problem is I don't remember the password to that anymore. I actually don't think I remember the email to that anymore. But there is a channel out there called The Mad Scientist. It has one video on it, with me being very, very frank about my first or about one of my hospitalizations. But anyway, but I like to make video. Most of my astronomy videos are lectures. I would like to make more targeted, smaller, 15 to 30-minute videos that are easily more digestible on specific aspects such as Kepler's laws or eclipses or things of that nature. Would I purchase an Edge HD 14-inch? It's funny you should say that. When I was out there indoctrinating the youth at a local elementary school, someone came up with an 11-inch Edge Celestron. I think it was an Edge, but I don't know. I'm not familiar with that particular model. What I will say about about size and how it matters, we in astronomy love bigger is better. Very quickly, the reason why a bigger telescope is better than a smaller telescope is that it collects more light. That allows you to see dimmer objects. It also allows you to see finer detail in those objects. If you were to look it up, I would not be surprised that it would claim that 14-inch telescope is portable. Sure. Yeah, you can port it around. I wouldn't. If I had for my own sake, I do not wish to transport a telescope any larger than, so 8 inches or less, I will happily put in a car, take out into the field and do whatever. If you have a bigger telescope, like a 10-inch, then yeah, you could put it out on the lawn, maybe take it, set it up, take it down. If you got a 12 and particularly a 14, you're going to have to go with Bob the Science Guy. Those of you who are not subscribed to Bob's channel, subscribe to Bob the Science Guy. And also, oh Lord, Judy, help me out. What is his observatory called? You could put that in the channel as well. Bob has basically, with Judy's help, sunk a lot of money into building a small dome observatory, and he has a very nice telescope in there who's, again, it's a Rasa. I can't remember the size of it. But if you're going to get a 14-inch or a 16-inch or 12-inch, recommend doing that. I would recommend going full out and building a structure to house the thing, because setting that up is a bear. Shamrock Bank Observatory, thank you. Yeah, I would not be surprised. I was fully expecting that, actually. So if you want to see the eclipse live streamed, I think then definitely go over there and check it out. Like I said, I will be taking a video of it, but unfortunately, I've yet to figure out how to do that with the C-Star and live stream at the same time. Yeah, Bob's setup is I have lucked out because I have always been in an institution that has observatories, so I haven't had to actually do what he's done and build my own setup and put it together. And mad respect for what he's got over there. I can tell you that there's a lot behind the scenes when it comes to operating telescopes they're behind the scenes. You don't know about them. The amount of maintenance, the amount of setup that goes into these systems is immense, and it is it's not something to be taken lightly. So definitely kudos to him. Yeah. Is Bob thinking of buying a 14-inch edge? I've got a couple of 12s that were in storage. I finally got some funding to buy new mounts for them because they're the old mounts, the old fork mounts were toast. These things are probably from early aughts, maybe. They're definitely 20 years older. And so the mounts are kaput. So I stripped the OTA, the tube off, and I put them on new mounts. And one of them is currently residing on the deck of our observatory. It's got a cover on it. It's not schwanky. It's not a dome. Frankly, there really isn't room for a dome, so cover would have to do. I'm fairly convinced with how well it can protect things. So sometime next week, I'm going to be putting the second 12-inch up there and doing a similar treatment. Oh, okay. Man, I gotta say, I wish I had that kind of money. Yeah, I wish I had that kind of money. I know that he gets a lot of backing from his community, which is, kudos for him. But yeah, given the state of academia and ordinarily, and then given the current state of funding and all of that fun business, I am certainly not going to be shelling out for a 14-inch telescope anytime soon, particularly since I've got a 12 on the roof. I got a 32 that I can play with, although that I could go on for hours about how the 32-inch telescope is becoming the bane of my existence. But yeah. All right. Unless anyone has any more questions, I'm going to call it for tonight, and I'm probably going to go home despite my drinking coffee. I'm probably going to go home and try to relax a little bit before I come back out here and try taking a video of it. I am and will forever be Professor Parks, PhD. I make content on astronomy, science skepticism, and mental health. If you like that sort of thing, please like, share, and subscribe. Hit that bell for notifications because I have no regular schedule. So yeah. To make sure that you know that the videos are being put out or that I'm going live, you're gonna definitely need to hit that like button. If you like what you see, please share it around. Yeah, I think that's it for now. So I'll make sure that I've got my outro. Peace out. Clear skies.